Now, welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AS Maths past paper of June 2024, paper 2, section A, which is the pure section. Now, before we get started on this paper, a little reminder that I'll include a question breakdown in the description so you can see which question refers to which topic. So if you get stuck on a question, you can see what topic it refers to and maybe go back and revise that topic. And I'll also include a link to the 162 Maths contents page, which gives you easy access to all my AS and A2 videos, along with all the other exam paper walkthroughs in the description as well. So let's get started on question 1. So question 1 reads, line L has the equation of 5y equals 4x plus 6. Find the gradient of a line parallel to line L, and we need to circle our answer. Now for this question, what we need to do is first of all make y the subject, so we can then use y equals mx plus c to find out what the m value is going to be. So for this we need to get y by itself, we need to divide everything by 5. So that's going to leave me with y equals 4 over 5x plus 6 over 5. And then working out the gradient value, which is 4/5, I just need to circle the right answer, which is our third option. For question 2, it says one of the equations below is true for all values of x. Identify the correct equation. So for this, what we're looking for is a correct trig identity, in which, if you've done your revision, you should notice that it's the third box that we need to tick. Moving on to question 3, it says it is given that 3 log x equals log 72 minus 2 log 3. Solve the equation to find the value of x. Now for this, what we need to do is first of all recognize the laws of logs and understand what we can do with these. So our next line is to write it as log a to the x, and we can take that 3 as a power, equals log a to the 72 minus log a to the 3 squared. Now from this, what we can then do is we then need to write the right hand side as a single logarithm. Now when we are taken away, that is when we divide. So log ax to the cubed equals log a, and that's going to be 72 over 3 squared, which is 9, which gives us a simplified answer of log to the base a x cubed to log a, and 72 divided by 9 gives me 8. Then from this, what we can then do is we can remove the logs from both sides, in which then what we're left with is we're left with x cubed equals 8. So x is going to equal the cube root of 8, leaving me with my final answer of that x equals 2. Moving on to question 4, it says curve C has the equation of y equals 8 sine x, and for part 8 it says curve C is transformed onto curve C1 by the translation vector of 0, 4. Find the equation of C1. Now this is basically going to be a shift up of 4, so then we need to shift this equation up by 4. So what we then need to do is add 4 to that equation, so it's going to be 8 sine x plus 4. For question B, it says curve C is transformed onto the curve C2 by a stretch of scale factor of 4 in the y direction. Find the equation of C2. Now, stretching in the scale factor 4 in the y direction is basically multiplying the equation by 4. So here we're going to have y equals 4 times 8 sine, and it's x. So that leaves me with a final answer of y equals 32 sine x. Then for part C, it then says curve C is transformed onto a curve C3 by a stretch of scale factor of 2 in the x direction. So to perform this transformation, what we need to do is multiply the value of x. So multiply x by a half. So if we do that, what we end up with is y equals 8 sine, and then we halve the x value, so that is what we get as our final answer. Moving on to question 5, it says that a student suggests that for any positive integer of n, the value of the expression 4n squared plus 3 is always a prime number. Prove that the student statement is false by finding a counter example. Fully justify your answer. Well, if we substitute n equals 1 into this, then what that's going to do is that 4n squared plus 3 is going to equal 7, which is a prime number. Then if we substitute n equals 2 into 4n squared plus 3, I'm going to get an answer of 19, which is also prime. Then we substitute n equals 3 into 4n squared plus 3, in which I get an answer of 39, which is not prime. So therefore, as 39 equals, now if you ever want to prove that number is not prime number, write it as a product of their prime. So show that there's more than different factors apart from one and itself. So here we can write 39. So as 39 equals 3 times 13, it's not prime. And there we go. Then moving on to question 6, it says in the expansion of 3 plus 8x to the power of n, where a and n are integers, the coefficient of x squared is 4,860. And for part A is asking us to show that 3 to the power of n, a to the squared n multiplied by n minus 1 is equal to 87,480. So for this, what we need to do now, depending on your way of using binomial expansion, this is where you're going to have to use the formulas for it to make sense, I would say. So looking at the formula for the coefficient of x squared, what we have is we'll have n minus 1 over 2, because our x value is looking at x squared, multiplied by 3, and then what we end up with is n minus 2 multiplied by a squared equals 4860. Now from this, if I look at this particular part here, I can rewrite 3n to the minus 2 as 3n over 3 squared. So when I write the next stage, what we end up with is we end up with n minus 1 over 2 multiplied. Now instead of writing 3n to the power, or to the 3 to the power of n minus 2, I'm going to write 3n over 9 because it's 3 squared multiplied by a squared equals 4860. Then from this, what we can then do is we can take 2 times 9, which is 18, and we multiply that over to this side. So what we end up with is n minus 1 multiplied by 3n multiplied by a squared equals 4,860 multiplied by 18, which gives me an answer of 87480. And then I can just neaten all of this up. So 3 to the power of n, a squared n minus 1 equals 87480, which is exactly what they wanted me to show. Now moving down to question B, it says the constant term in the expansion is 729. If the coefficient of x in the expansion is negative, verify that n equals 6. So for this, looking at the above expression from this point here, then what we establish is from the original expansion here that our constant is going to be 3n, or 3 to the power of n. So that means that 3 to the power of n is equal to 729. And what I want to do is I want to show that n equals 9. So using logs, I get log of base 3, 729 equals n. And then all I have to do is then type this into my calculator, which most modern calculators you can do now, where you can write it with the base, in which I get an n value of 6. Now moving on to part 2, it says find the value of a. Now if I recall what I discovered in part A, which was that 3n, or 3 to the power n, a squared, and then we had n minus 1 equals, and it was 87480. Now we know that 3n, or 3 to the power of n, is 6. Sorry, is 729. We also know that n equals 6. So if I substitute these things into this expression here, then what I end up with is 729 a squared, and then I'm going to end up with multiplied by 6 minus 1 equals 87480. So what we end up with is 729 a squared multiplied by 6 multiplied by 5 equals 87480. And then if I simplify all of this, if I just reach for my calculator, I've got 729 multiplied by 6 multiplied by 5 gives me 21870 a squared equals 87480. Take this to the other side, in which I end up with an a squared value of 4. And then from this, what we establish is we get a value of either plus or minus 2. Now, what we need to be careful of is, one, don't underline this because this is not the final answer, because a needs to be one value. If we go back to part BI, it states that this x equals, or the x expansion is negative. Now, from this, as it says that the coefficient of x is negative, however, the expansion of x squared is positive, it means then we're going to have an oscillating sequence. So it's going to go plus minus, plus minus, plus minus. Now, because all of the variables are positive, that means that a must be the controlling factor that makes it oscillate. So therefore, the a value must be minus 2. So it's really important that you state that, because if you write plus or minus 2, you will lose a mark. Now, moving down to question 7, it says point A has the coordinate of 4, 1 and point B has the coordinate of minus 8, 5. And for part A, it's asking for find the equation of the perpendicular bisector of AB. So for this, the first thing we need to do is find the gradient of AB. And we do that by using the formula of y2 minus y1 over x2 minus x1. So substituting the coordinates in, again, depending on which one you call the first one, which one you call the second one. But I'm going to go for 5 minus 1 over minus 8 minus 4, in which I get a gradient of 4 over minus 12, which gives me a gradient of minus 1/3. Now from this, what we then established that the gradient of the perpendicular bisector is going to be minus 1 multiplied by 1 minus 1/3, which gives me an answer of 3. Then from this, what we then need to do is then find the midpoint of AB, in which we then do minus 8 plus 4 over 2 to find out x ordinate, and 5 plus 1 over 2 to find out y ordinate, in which that gives me a coordinate of minus 2, 3. Then using those two bits of information, I'm going to substitute that into y minus y1 equals mx minus x1, in which I get y minus 3 equals 3 lots of x plus 2. Expanding the brackets out and simplifying, I get my final answer of y equals 3x plus 9. Now moving on to part B, let's just move the screen across so we've got a bit more room. It says that a circle passes through the points AB. The diameter of the circle lies along the x-axis. Find the equation of the circle. So let's have a look at what this potentially looks like. Now, because my circle drawing freehand is a bit sketchy, let's just draw a circle here. And let's have a look at what the axes are generally going to look like. Now, just make a little sketch of where those axes are going to be in relation. So we know that the diameter goes through the x-axis. And we can say that point B is here. And point A is going to be somewhere here. Now, the perpendicular bisector of a chord, which is, let's do that in a different colour, so let me just get rid of that line. Let's use a different colour. Will always go through the centre. So this line here, which we've worked out in part A, is y equals 3x plus 9. Now we know that it goes through this point here, so we know that the y ordinate of the centre of the equation is going to be at 0. So here, at the centre, the y ord is going to equal 0. So if we look back at the equation of a circle, which looks something like this, we know that b is going to equal 0. So what we've got is a minus x minus a squared plus y squared equals r squared. Now, to find the radius, all we need to do is find the distance between the centre to, let's say, point A. So we just need to find out what, running out of colours, what this distance here is. So to work that out, all I need to do is just use the formula of y2 minus y1 squared plus. Now, if you've got a different variation of this, that's absolutely fine as long as it's correct. You may have the brackets all the way around. But substitute numbers in, we get d equals the square root of 4 minus 3 squared plus 1 minus 0 squared. And that's going to give me root 50. So therefore, the radius equals root 50. So that's one bit we've got there. So we can write this as 50. And then it's just a case of finding out what the A value is. And so when, let's use a different colour. So using y equals 3x plus 9 when y equals 0, x is going to equal minus 3. So that's my y ordinate. So my equation of the circle is going to be x minus 3 squared. And that's going to be plus y squared equals 50. And there we go. In fact, there that should be a plus 3. So let me just find the right colour pen. There we go. And that's it. So moving on to question 8, it says prove that the graph of the curve with the equation of y equals x cubed plus 15x minus 18 over x has no stationary points. Now for this, you may not choose to do this, but I always like to write it using in the indices. So we get y equals x cubed plus 15x minus 18, and that's going to be x to the power of minus 1. Now from this, what we can then do is work out the dy dx, which is going to be 3x squared plus 15 plus 18x to the minus 2. Now at stationary points, what we know is that dy over dx equals 0. So what we can then do is make this expression equal to 0. So we get 3x squared plus 15 plus, and I'm going to write this as 18 over x squared equals 0. Now from this, what we want to try and do is solve this for x. So if I multiply everything by x squared, I'm going to end up with 3x to the power of 4 plus 15x squared plus 18 equals 0. Now from this, I can then notice that all the coefficients have a factor or multiple of 3. So I can divide everything by 3, in which I end up with x to the power of 4 plus 15x squared. No, it doesn't. It's going to be 5. Oh, completely demolish this question. There we go. And I'm going to end up with 5x squared plus 6 equals 0. Now, because obviously I don't like factorising with powers other than with a order of 2, what we can do is let y equal x squared. And if I let y equals x squared, what this then turns into is y squared plus 5y plus 6 equals 0. Now, what if I can then solve this, and I can solve this by factorising, I get y plus 2, y plus 3 equals 0. So therefore, y is going to equal minus 2 or minus 3. Now, if I substitute those values back into my substitution, what I then get is that x squared equals minus 2 or x squared equals minus 3. And the problem with this is that this can't happen. Okay, so there are no solutions. So therefore, there are no stationary points. And there we go. And it's really important that you do state that last statement that I've written in orange. Then moving on to question 9, it says that a curve has the equation of y equals ax minus a to the root x plus b, where a and b are constants. The curve intersects the line y equals 2 at points with the coordinates of 1, 2 and 9, 2 as shown in the diagram below. And for part A, it's asking us to show that a has a value of 4 and find the values of b. So for this, what we need to do is, looking at the graph, what we can establish is that when x equals 1, that y equals 2. So if I substitute that into the original equation here, so if I substitute those numbers into there, let's just write this over here so we've got it on screen. x minus a root x plus b. Now we can scroll down a little bit. There we go. In which then what we end up with, so substituting that into this equation here, I'm going to end up with 2 equals 1 minus a root 1 plus b. And simplifying all of that, what I end up with is minus a plus b equals 1. And that's one of my equations. Then, if I then look at the other coordinate, so when x equals 9, y equals 2, and I do the same, what I end up with is 2 equals 9 minus a root 9 plus b. Simplifying all of that, what I'm going to end up with is minus 7 equals minus 3a plus b. Now from this, what I then want to do is use simultaneous equations to solve this for a and b. So use simultaneous equations to find a and b. Now obviously do not write this in your test. You'll be actually working this out, and you can use your calculator for this, in which what you should end up with is a equals 4 and b equals 5. And there we go, we've shown that a equals 4 and we've found the value of b. Now moving on to question B, it says on the diagram the region enclosed between the curve and the line y equals minus 2 is shaded. Show that the area of this shaded region is 16 over 3. So for this, what we need to do is first of all look at y equals x minus 4 root x plus 5. So all I've done there is substituted my values of a and b from part A into the equation that was given. Now from this, what we then need to establish, I can write this as y equals x minus 4x to the power of a half plus 5. Now from this, what I then want to do is integrate this with regards to 9 to 1, in which I've got x minus 4x to the half plus 5, and we're differentiating that with regards, integrating that with respect to x. And again, you can use your calculator to do this, but I would always show working out. Don't like how the calculator can do this for you, but you could, depending on your calculator, do this automatically. But what we end up with is this expression here. By increasing the power and divided by the new power, we end up with 9 and 1. So by using this, we can then work out that the area under the curve is going to be equal to 32 over 3. And then we then need to work out the area of the rectangle, which is just base times height, which is going to be 2 times 8, which is 16. And so therefore the shaded area is going to be the area of the rectangle, which is the larger one, minus the area under the curve, and type that into my calculator, in which I get an answer of 16 over 3, which is what they wanted me to show. Now moving on to question 10. Bit of a wordy question. It says that a singer has a social media account with a number of followers. The singer releases a new song and a number of followers grows exponentially. The number of followers f may be modelled by the formula of f equals ae to the power of kt, where t is the number of days since the song was released and a and k are constants. 2 days after the song was released, the account has 2,050 followers, and after 5 days the song is released, the account has 9,200 followers. I want to be so fortunate. On the graph below, in ln f has been plotted against t for these two pieces of data. A line has been drawn passing through these two data points, in which we've got this here. Now the question is asking us to show that ln f equals ln a plus kt. So for this particular question, what we need to write is we've got f equals, now if I take the original formula of ae to the power of kt, then if I take the ln of both sides, so I end up with ln f equals ln, or let's not write it as a h, so we've got ln, I've done it again, I've got there we are, we've got ln a e of kt. Then I can write this as, or the right hand side as ln a plus, because it's been multiplied by ln e to the kt. Now ln and e will just cancel out, so that then becomes lnf equals lna plus kt, which is exactly what they wanted me to show. Then for part 2, it says using the graph, estimate the value of constant a and the value of constant k. So for this, what we know is that lna is equal to, and if we go back to the graph, that which is the y-intercept, so that's going to be 6.6. So then using e, we can then find out that the value of a is going to be e to the power of 6.6. That's going to give me an a value of 735. Now in terms of k, k is the gradient of the line. So if I go back to the graph and just pick two nice coordinates, in which I'm going to go for these two, in which it's 2 up and 4 across, with each little box representing 0.2. So what we end up with is a k value of 2 over 4, which is 0.5. So there's my value of a and my value of k. Now moving on to question BI, it says show that df over dt equals kf. Now for this, what we need to do is just remind ourselves that f equals a e to kt, which is given to you in the information in the question. So then differentiating this with respect to t, what we end up with is we're going to end up with, what we need to do is differentiate the power, move that to the front. So if we differentiate kt with respect to t, we end up with just k, and we end up with a e to the kt. Now from this, what we can establish is that this highlighted area is f. Is these two things here are the same. So what I can then do is replace this with f. So therefore that equals kf, which is what they wanted me to show. Moving on to part 2, it says using the model, estimate the rate in which the number of followers is increasing 5 days after the song was released. Now, as it says a highlight to the word rate, that means that you're going to be using df over dt. And it says after 5 days, so where t equals 5. So from this, what we can then establish is 0.5 multiplied by 9,200, which is given to you in information in the question, and that gives us an answer of 4,600. Then moving on to our last question, it says that the singer claims that 30 days after a song is released, the account will have more than 1 billion followers. Comment on the singer's claim. Now for this, we only know data, so we only have information on days 2 to 5 after the release. So therefore we can say that through extrapolation it's difficult to see how the claim is correct. So the model may not be applicable. So something along those lines would be absolutely fine. And looking at the scheme of work, it says these are possible answers you can get for this one single mark. You can say realistically the number of followers is too large. In reality, the number of followers will not continue to grow exponentially. The singer may do something which causes followers to unfollow or lose followers. Song may become less popular. The song may not be to that number of people's taste. The new songs may be released. No individual has a social media following of over 1 billion people. Well, that's questionable. Model may only be based upon 2 days and 5, which we said, and it's too much extrapolation on there. People are fickle and lose interest. And again, any possible answer around those would be absolutely fine for the single mark.